Hello, welcome back to NMI. In this video we're going to take a look at two very interesting operating systems for the Commodore 64. And the main reason I think they are interesting is because they are inspired by Unix. I'm talking about LUnix and GeckOS. Now let's take a look at LUnix. LUnix is a project that started when? 1993, and the objective is to implement a small version similar to the feeling of Linux, but on an 8-bit machine, and specifically the Commodore 64. So obviously it's a very limited operating system, but still, at least I find very impressive. It supports up to 32 tasks. It has dynamic memory management, two kinds of IPC pipes and signals. It has support for the external RAM interface. It also supports the RAM expansion unit, the super CPU, and a number of features that I wanted to try. Of course, one thing that I did already was to try it on the Vice emulator, but it's not the same thing. I wanted really to try it on the real thing, on the actual hardware. So if you're interested, the sources for the Linux are on SourceForge, but for now what I'm gonna do is to take one of those images that they have available there, and I'm gonna give it a try. First I'm gonna show you it running on Vice, and then we're gonna see it running on the real machine. Another very interesting feature is that Linux supports TCP/IP stack, right? So basically it's possible to use Linux and connect your Commodore 64 to the internet via a serial link using SLEEP or PPP. And it can also, that is almost insane. You can also have a terminal server, so you can start a remote console via serial connection. Maybe we can try that on the emulator, because I don't have any hardware for the serial port on my Commodore 64s. So, oh yeah, and another feature that I find very nice is the history function on the shell. It has a shell, obviously, and anyway, it's pretty interesting. And oh yeah, see, a web server. Anyway, let's take a look, and we are gonna see what Linux is capable of. Okay, we have Vice running here now. And this image is already loaded on drive 8. Oops, on drive 8. So let's load Linux there. Yeah, it's working, it's running. Oh, here we go. Interesting. Maybe I have to reconfigure my emulated 64 because it's PAL 50 Hertz. Anyway, it doesn't change anything right now. And here we are. We have the console. Well, let's see. We have ls. Yeah. Oh, it's listing the disk contents. Okay. Oh, Q. Okay. What else we have? Hello.sh. I know that it also supports cat. So let's take a look at what is inside hello.sh. Echo. Oh, okay. So it also supports echo. So we can we run hello? Well, it's slow, right? Because this is a Commodore 64. It's not like an Intel or AMD machine. It's not a multi-gigahertz processor. We're talking about a processor that has less than 1 megahertz clock. And here we have hello world. Okay. So let's try a PS. Oh, see, we have a number of processes. That's pretty cool. That's an operating system. For real. What else can we do? Do we have device? No, we don't. Oh, okay, so we have a disk 8, a disk 9, a console, and a pipe. Oh, of course, yeah. Can we do this? No. Okay, so what else can we do? Do we have uname? Cool. L and G because this is, as they state here, is Linux next generation, right? Yeah, Linux next generation. So that's why L and G. That's pretty cool. Okay, now let's take a look at Linux. LSH. Oh, what is wrong? It's not working. So, oh yeah, the problem is that it's trying to load from the, let me zoom out. When I try to load the shell, it tries to read the floppy drive. Yeah, and that's because Kung Fu Flash is not really a floppy emulator. So here we are. And looking at the limitations of Kung Fu Flash, we can find this. So the way, because Kung Fu Flash is not a floppy drive emulator, right? It doesn't even connect to the floppy drive connector. So what Kung Fu Flash is doing is, as the author states here, disk emulation using kernel vectors. So basically, when there is a system call to one of the disk or file functions on the kernel, Kung Fu Flash intercepts that call and then makes the magic happen. I mean, inside the disk image that is emulating, so it's gonna use that image instead of the actual floppy controller, right? But as the author states here, it only emulates a subset of Commodore DOS commands, and so there's a lot of software and fast loaders that use direct hardware access right here. So maybe that's the reason why we can't make the OSs work. So okay, that is sad. But looking here, another feature of Kung Fu Flash is that it implements Easy Flash 3 USB protocol. And one cool thing about this is that you can use Kung Fu Flash to transfer images from the PC that acts as a host to a floppy drive controller through the Commodore 64. So basically you have the PC transferring data to the Kung Fu Flash in Easy Flash 3 mode. Then it pipes the operations through the Commodore 64 to the floppy drive, so we can write a physical disk with an image that is on my computer, and that's what I'm gonna do. So basically we have to use these utilities here. I'm on Linux, so I'm gonna have, is there a version for, yeah, this is the Linux version. So let's give it a try. Okay, now I have a floppy disk inserted on the floppy drive that is behind me, that one, that the 1541 that has the green LED on. I have a USB cable connecting the Kung Fu Flash to this machine, and if we do ls USB, yeah, here it is. This is our Kung Fu Flash. Now ls tty, no, ACM0, that is our USB device, the virtual COM port. Now I am inside the repository, so let's go to third party, and to EF3 utils, and we have the EF3 USB there, F3 USB, and here we have the options. So we can execute a file, we can copy, transfer, write, read, we can get a dir, a directory, format, write a tape file, make a tape file, burn. Oh, okay, so these options are for the EF3 mode. And okay, so if we look the repository, where is it? Here? Can we see it here? Yes, we can. Yeah. So first we need to start the command with the option S, and the option S is send a file. And the trick here is if we just type use the option S, we send the ef3 usb.prg. So that is a special file that is like host software that is going to run on the Commodore 64, and that is going to connect to our PC, right? So let's try it. Do I have the PRG? Yes, the PRG is here. So we can do 3 USB S. Oh, of course, we need the device. So dev tty acm0s. Done. See? And in the screen behind me, you're seeing on the video, we now see the menu, right? So the device is 8, correct? Now we can send a file. So where is my file? Oh, I have Linux ID. Okay, I'm gonna copy. Okay, now we have our file here, linux.d64. Why ls again? So we're gonna have to now write. We're gonna use the option write, and linux.d64, and we should see action now on the floppy drive on that machine. See? Oh, it just frozen here and there. So there is something wrong. Okay, I'm back. I did some research and tried different options, and if we look here at the options, we can see that the write command has a verify and a kernel option, right? And I found that the kernel option bypasses a fast write that is built into the application, and that's probably what is causing the issue. So what we have to do is to use the write command here, but with the kernel option. Kernel. Oh no, it's after, right? So kernel. Let's try it. Oh, see, now it's moving. It doesn't get stuck, and we can see progress. This is gonna take some time. It's writing each track. There are 35 tracks. Done. Now we can test this Linux image. Okay, I have the floppy image that we imaged. It's already there. Let's load. And see what happens. I hope it works. Okay. It's cool that on this machine it detects as an NTSC and 60 Hertz, which is obviously the right configuration here. Have a lot of fun. Yes, I will. So, you name. Let's see what it tells us. Oh, that is different from the emulator. I don't know why. And the cool thing is that we have that's pretty cool, right? For an 8-bit machine, we have the history. Let's see, uname -a. Does it work? Or gives us anything different? Oh yeah, okay. Yeah, awesome. ls. There is a number of commands and files in this disk. Let's try hello.sh. Yeah, cool. Now let me try the multi-terminal support. I'm gonna press F3. Here we have the loader. So LSH, and this should start a new shell. And then we're gonna, yeah, cool. So now we have 2 shells. If I press F1, we are on the first shell, and F3. Oh, that is amazing, isn't it? And now we have 2 shells running at the same time. Oh, sorry. Oh, yeah, started 3 shells now. Yeah, I wanted to do a PS. Okay, so let's exit this third shell. Yeah, okay. And now if we do a PS, yeah, that is pretty cool. So this is it. Linux is pretty cool, isn't it? I really think it's an amazing operating system. It's very impressive what it can achieve in such a small machine like the Commodore 64. What is not so nice about Linux is that, as we can see on the website, it was last updated in 2004, so 20 years ago. If we try to look at the SourceForge, we get an error, right? So that's not very nice. That is because it is unmaintained ever since. I managed to find, let me show you, the SourceForge page for Linux, as we can see here, and we can download the code from there and floppy images. The problem again is that this is sourced from 20 years ago, right? And the reason I'm bringing this up is because I wanted to maybe write some code that could run on Linux. So let me show you. I have a terminal window here. ls. So we are on the repository, on Linux repository, and if we try, there is a makefile there, and if we try to make, we get a lot of errors, right? So some of these, or most of these errors are related to, like we can see, Atari, Devil, like utils Atari. So that's trying to build some development utilities for Atari. I'm not interested on Atari right now. So if we look at the makefile, we're gonna see here that it's trying to build stuff inside Atari and Apple. So I'm gonna comment out these two lines, right? And we can try to make again, make. And now it is successful. And it took me some time, but if we look at the makefile again, there's gonna be a target, which is make disk, that is gonna generate a disk image. And now if we do a ls -l, we're gonna see here, this is a fresh Linux disk image that was generated or built right now, right? So that's pretty cool. You can use that image to run or to image a floppy disk, or use another device to check it out on your Commodore 64 or on Vice, right? So this is one thing, but I wanted also to maybe write my own application. And if we go to samples here, you're gonna see that there is a number of folders: CA65, CC65, Luna, makefile, whatever, SCC 6502, and there's a makefile here. And if we type make, it fails. And right now the reason is that it can't find Lupo and it can't find Luna. But also you can see here that it's calling CA65, right? And when it tries to run CA65, which is the assembler, there is an error. The meaning of -L has changed. So why? Because this is a 20-year-old source code that was not updated. So CC65 moved forward, right? It continued to get updates and evolved, but this code didn't evolve alongside CC65. So that means that we're going to be unable to compile this code at this time. I might go there and try to understand what is wrong and maybe fix it. But the bottom line is we are unable as it is to compile these codes from the samples folder, right? For this reason, I decided to look into another operating system for the Commodore 64, and that operating system is GeckOS. Let me show you. So this is GeckOS A65. So this is a project that started by a single person, Andre Fachat. I don't know if I'm pronouncing his name correctly. From 1989, and it's still maintained. So that is a pretty cool thing, right? I was reading here his website, and he designed this operating system to support his own machine that he designed from scratch, which is called A65, and that is based on a 6502. But it's pretty cool because it actually includes memory management unit, MMU. So that is really amazing. That machine, we probably should have a video on it just for the sake of how amazing it is. But right now, that's not what we're gonna do here. What I'm gonna do is that we're gonna take a look at GeckOS. And another pretty cool thing about GeckOS is that it has its own GitHub repository. Let me show you here, right? And we can see that this operating system is maintained. It's currently maintained, right? We can see here that there are commits that are maybe a month old. So that is another very nice thing. So GeckOS is also a kind of a little limited Unix implementation. It's slightly different than Linux, but it's also pretty cool. It lacks some features. As far as I could see, there's no support for the history on the shell. It doesn't support the multiple terminals, but nevertheless, it's pretty cool, and that's what we're gonna see next. Okay, now it's time for testing GeckOS. So I have the D64 here already, and the 64 is running the host application. All we have to do is, and I have the other floppy, a new floppy disk on my drive 8. So let's copy. Oh, GeckOS 64. What? Oh, this is 464K, of course. Okay, now I have the right image. 170K. Oh, wait. Oh, it's in the wrong place. Okay, now I have the image here. So let's try again to write. And it is writing now. Okay, done. Now it's time to try GeckOS.
Oh yeah, it's just hello. This is the code that we changed. We can start a new shell. I'm not sure we can do multiple terminals as we saw on Linux. So now we are in a new shell. Oh yeah, I forgot to do uname on Linux. But here, yeah, we can see GeckOS 2.2, 6510. That's it. It's a pretty cool OS. Oh yeah, and we can see here that we have two shells running, right? PID2A and PID38. So I can kill PID38. And now if we do a PS, we should only see the CLSH. Yeah, see? Only the 2A. And now PID38 is us, the PS. It's a pretty cool OS implementation. Congratulations to Andre, and I hope this keeps developing, because I find that pretty cool. It's mini Linux running on the Commodore 64.
Well, that's it for this video. I hope you enjoyed it. Linux and GeckOS are pretty amazing operating systems, sort of mini Linux as we saw, and I'm planning in the future to explore more on not only on these operating systems but maybe other operating systems for the Commodore 64 and these 8-bit machines. Anyway, thanks for watching, and if you enjoyed this content, please subscribe for more videos like this, and see you next time. Bye.